According to astronomers, 3 Atlas has all kinds of surprises. We've only seen a handful of blurry shots that look like a tail is kind of starting to form. Tonight on The Future of Everything, we've got 3I Atlas updates and maybe even our best shot yet to clearly see the third interstellar object last week. It could be the oldest comet ever seen. The moment was nothing short of mind-bending. Imagine a comet, a visitor from the stars, moving through our solar system at immense speeds, a hyperbolic path defying the sun's gravitational pull, blazing a trail through space with an intensity we've only ever witnessed in textbooks. But then it happened, the comet froze. That's right, a cosmic object traveling at tens of kilometers/s suddenly appeared to cease motion altogether. It's not a momentary flicker, no, it was a long enough pause to baffle even the most seasoned astronomers. The data was irrefutable. For a short period, 3I/At was not moving through space, it was stationary. For the scientific community, the implications were profound. The laws of physics as we know them were seemingly put to the test. Objects in space, especially those on a hyperbolic trajectory, follow certain rules, speed up as they fall into the sun's gravitational pull, then decelerate as they head back into deep space, but this was no ordinary cometary behavior. And that's where the mystery begins. What happened next? Stay tuned because this isn't just another astronomical curiosity, this moment could change how we view the very mechanics of celestial bodies, opening the door to a whole new realm of possibilities. But before we dive deeper, smash the like and subscribe buttons to stay updated on this extraordinary tale from the cosmos. The discovery of 3I/Atlas was a monumental event for astronomers. First identified as an interstellar object, 3/ aimed attention for being part of a very exclusive group, objects that come from beyond our solar system. While we've seen a few interstellar objects pass through our neighborhood, this one was different. This comet, like a cosmic wanderer, entered our solar system on a hyperbolic trajectory. Its velocity was unlike anything seen before, and it wasn't bound to our sun. It would pass through, interact with our gravitational field, and then continue its journey out of the solar system. It was never meant to stay. Astronomers had only just started to track the comet's path when its first few observations left them intrigued. It had all the hallmarks of a typical comet. As it approached the sun, it began to outgas, forming a coma and leaving behind a trail of dust and gas, a common feature of comets. What made 3I/At stand out, however, was its origin. Unlike other comets in our solar system which are thought to have originated from the Oort cloud or the Kuiper belt, 3I/At came from somewhere far beyond our cosmic neighborhood. Its appearance was a rare event, providing astronomers with the opportunity to study a comet from outside the solar system, an object that had carried its secrets across the galaxy. Its course was meticulously mapped by astronomers and its brightness measured. The comet's velocity, its tail, and even its spectral signature, indications of what elements were present in the comet's makeup, seemed to fit the patterns of what we would expect from an ordinary comet, albeit one of exceptional origin. Its path was calculated with precision, and everything seemed to be in line with predictions. However, things were about to change in the most unexpected way. Then came the inexplicable moment. As March 8 neared its closest approach to the sun, astronomers expected to see a typical cometary behavior. Outgassing, brightening, and a well-defined tail were all anticipated as it continued its approach. But as the comet passed the critical point in its orbit, something baffling happened. The comet, which had been streaking across the night sky, appeared to stop completely. At first, it was thought to be an error, a fluke, maybe a tracking error, or an issue with one of the observatories. But as the minutes turned into hours, multiple telescopes across the globe confirmed the same result. 3I/Atlas was no longer moving. In fact, it appeared completely stationary against the backdrop of the stars. It wasn't just a small misalignment, it was a real sustained phenomenon. Astronomers were left in stunned disbelief. An object on a hyperbolic trajectory should never simply stop. Objects in space are governed by Newtonian physics, motion, acceleration, and gravity. But this comet was not playing by the rules. It seemed as though it had become a still point in an otherwise dynamic universe. The data from multiple observatories confirmed this was not a fluke or an artifact. The object had stopped moving. For hours, the scientific community was at a loss for words. The implications were staggering. Motion in space is so fundamental to celestial mechanics that this anomaly threatened the very foundation of what we knew to be true. How could a comet, an object careening through space at incredible speeds, simply cease motion? Could it be some unknown force acting on the object? Could there be something we hadn't yet discovered in the laws of physics? The reactions were swift. Astronomers scrambled to double-check their data, confirm the calibration of their instruments, and rule out every possible error. But everything checked out. The comet was not moving. The theories began to pour in. Was this some sort of cosmic illusion? Could there be an optical effect causing the object to appear stationary? Perhaps overlapping exposures or some other instrument anomaly was creating the illusion of stasis. But this seemed unlikely. The event lasted far too long for it to be an artifact of any kind. With the mystery deepening, astronomers began to propose various theories. One of the first hypotheses considered was the idea of an optical illusion. Perhaps the comet's motion had been misaligned with the instruments, creating the illusion of stasis. Could overlapping exposures have caused the comet to appear frozen in time? However, after running multiple tests and cross-checking the data from various observatories, this theory was ruled out. The comet's position remained stationary across multiple platforms, from ground-based telescopes to space observatories. This was no illusion. Something was genuinely different about 3I/Atlas. Next, scientists turned their attention to non-gravitational forces. Comets are notorious for unpredictable behavior due to the jets of gas that erupt from their surfaces. These gas jets can impart small thrusts on the comet, slightly altering its trajectory. In some cases, these jets can cause noticeable changes in the comet's path. But for 3I/At, the forces required to stop its motion would be enormous, especially considering its high velocity. Even with a significant jet turning on in the opposite direction of its motion, it seemed unlikely that such a force could entirely halt its movement, especially without leaving any observable traces in the comet's tail or spectral signature. The magnitude of thrust required didn't add up. This theory too failed to provide a satisfying explanation. A more radical theory began to take shape. Some scientists wondered if March 8 music was interacting with some unknown forces or fields. Could it be that the comet, instead of behaving like a typical celestial body, was experiencing some type of interaction with the solar wind or even magnetic fields in space? This line of thinking suggested that 3I/Ls might not be just a passive comet, but an object interacting with forces we don't fully understand. Could magnetic fields, solar wind, plasma, or even localized anomalies in spacetime have created a situation where the object appeared stationary? Some scientists even entertained the idea that 3II/Atlas was interacting with dark matter or some form of advanced propulsion technology, perhaps extraterrestrial in nature. Though the idea was far from mainstream, the sheer mystery of the event pushed scientists to entertain even the most far-fetched possibilities. The search for answers intensified as the mystery deepened. Astronomers around the world were scrambling. The global network of observatories, each a sentinel in the vastness of space, was working overtime. The team responsible for tracking 3I/Atlas was tasked with conducting a thorough investigation, double-checking every piece of data, recalibrating instruments, and reviewing every observation to ensure there were no errors. Could this be a mere misalignment of telescopes, a malfunctioning piece of equipment? Could it be a processing issue with the data? But as the hours ticked by, the observations came back unchanged. This wasn't a case of equipment failure or misalignment. The comet wasn't moving. Every observational platform, from ground-based to space-based telescopes, confirmed the same result. It wasn't a fluke. It was a phenomenon that warranted serious scrutiny. The community's focus shifted from technical explanations to more theoretical ones. Could this be a previously unknown physical phenomenon? As scientists continued to analyze the data, they began to rule out the simpler explanations and delve into more complex possibilities. The more they examined the data, the more they realized that this wasn't just a curiosity. It was a potential breakthrough in understanding how celestial bodies behave when they come from beyond our solar system. Meanwhile, space agencies like NASA and ESA, European Space Agency, took note of the event, shifting their focus to this comet, now more than just an interstellar visitor. It had become a cosmic anomaly, a riddle that demanded a solution. Teams of astrophysicists and physicists began collaborating on models and theories, eager to find a plausible explanation for this unprecedented behavior. Would it be a simple natural phenomenon or a sign of something more profound? Could there be unknown forces or cosmic events at play? As these questions lingered, astronomers continued their relentless pursuit of the truth, determined to uncover what had caused the object to pause, even if they had to rewrite textbooks in the process. The spectrographic data that had been collected during 3I/Atlas's pass by the Sun offered further clues. As astronomers and researchers pored over the comet's chemical signature, they noticed something intriguing. March 8 had an unusual composition, one that differed from typical comets observed in our solar system. Its coma, the cloud of gas and dust that surrounded it, was rich in carbon dioxide. CO2, a volatile compound that's usually less common in comets, especially at such distances from the Sun. The ratio of CO2 to water and carbon monoxide was notably high, suggesting that the comet's volatile composition might reflect an origin in a much colder, more remote region of space. This peculiar chemical signature hinted that the comet could have formed in a different environment, possibly even before our solar system came into existence. Its exposure to the Sun was triggering sublimation of the volatile compounds, and that process could have been part of what caused the temporary halt in its movement. The data from infrared telescopes also revealed something odd. The comet's surface temperature fluctuated in a way that defied expectations. Normally, a comet's surface temperature is relatively stable, gradually warming as it nears the Sun and then cooling again as it moves away. However, 3I/Atlas exhibited oscillations in its thermal signature, suggesting bursts of heating and cooling that didn't correlate with its distance from the Sun. These temperature changes hinted at internal processes, such as pockets of volatile gases trapped inside the comet's nucleus. When these gases were released, they might have caused a sudden burst of energy, propelling the comet into a brief period of stasis. Such complex thermal behavior could explain the halt. If March 8 was undergoing a sudden release of trapped volatile gases, it might have created a thrust that temporarily counteracted its orbital motion. The delicate balance between the release of these gases and the comet's trajectory could have caused it to pause in space only to resume motion once the gas release subsided. The chemical composition and behavior of 3I/At was starting to paint a picture of an object that was not just a simple icy rock, but a dynamic volatile body that responded in ways we didn't yet understand. And this was just the beginning. As the mystery continued to unfold, scientists began to entertain more radical theories. Could the pause be the result of an interaction with unknown forces or fields? Some theorists propose that 3I/At might not be acting alone, but instead could be interacting with the solar wind, magnetic fields, or even something more exotic like dark matter. The idea of dark matter influencing the motion of celestial bodies was intriguing but highly speculative. Could this object on its journey from interstellar space have encountered fields or particles that caused it to temporarily halt? As strange as it sounds, some scientists started to seriously consider this possibility. Perhaps the object wasn't simply drifting through space in a predictable manner. Maybe it was interacting with unknown forces, something we didn't have the technology to measure yet. The more they examined the data, the more they wondered if the object's strange behavior was an indication of something we'd missed entirely. Could there be fields at play that we didn't even know existed? Could the comet's motion have been subtly altered by magnetic forces that we had never accounted for before? Meanwhile, other theories turned to the idea of a more complex interaction between the object and the heliosphere, the bubble of charged particles surrounding the Sun. This region of space is far from uniform, with turbulent interactions taking place between the solar wind and cosmic particles. It's possible that 3I/Atlas, due to its unique composition and trajectory, had entered a section of space where its movement was being influenced by these turbulent interactions. Another intriguing possibility emerged from the field of magnetohydrodynamics (MHD). MHD is the study of magnetic fields in electrically conductive fluids. And some researchers speculated that 3I/At might have contained enough metallic material to interact with the Sun's magnetic field in such a way that it temporarily halted its motion. Could the comet's metallic elements have created a coupling with the solar magnetic fields, causing it to freeze in place for a brief period? Such theories were radical, but they weren't out of the question. The more researchers thought about it, the more they realized that the universe was full of unknowns. And the idea of 3I/At being influenced by forces beyond our understanding was starting to make more sense. It wasn't just about the comet's behavior. It was about the nature of the universe itself. Could it be that 3I/ATI was revealing new dimensions of the cosmos that we had never considered before? The moment of stasis lasted only a short while, but the implications were far-reaching. Once 3I/At resumed its journey, the scientific community exhaled in relief. But that moment of stillness had already sent shock waves through the world of astrophysics.